Okay, let's unpack this today. We spend a massive amount of time obsessing over the flashy stuff in broadcasting.
Oh yeah, the 4K cameras, the massive video walls.
Exactly, the expensive matrix switchers. But we rarely talk about the unsung hero that actually makes any of that possible for you.
You mean the physical infrastructure, the actual nervous system of the setup.
Right, the cable. Specifically today, we are doing a deep dive into the Kramer BC-RG63G-152M.
It is definitely a mouthful of a name.
It really is. But if you are moving high-definition video over long distances, this is apparently the lifeline you need.
Right, and we're pulling our data today from HDTD supply, looking at the specs, the engineering, and even what the installers are saying.
Because it's a great example of why details matter. On the surface, it's just a spool of black wire.
But the mission of this specific cable is high-performance broadcast. It's an RG6 coaxial cable designed specifically for 3G HD-SDI signals.
Okay, let's start with that 3G HD-SDI part. Because when I hear 3G, my brain goes straight back to old cellular networks.
Oh, right, slow internet.
Yeah, I assume that is not what we're talking about here.
Definitely not. In the broadcast world, SDI stands for Serial Digital Interface.
Which is the professional standard for video.
Exactly. And the 3G refers to the bandwidth you need to push uncompressed high-definition video, specifically 3 gigabits per second.
Wow.
Yeah. And the fascinating thing about this Kramer cable is the distance. The specs highlight that it's optimized for a system range of 500 feet.
Or about 152 meters.
Right.
That is a massive distance for HD video without using fiber optics. Usually HDMI gives up after what, like 50 feet?
Precisely. And the source material notes it's specifically optimized for Sierra Aspen 3G HD-SDI routers.
So the engineering challenge here is how do you build a copper road that can carry that much traffic for that long without the signal falling apart?
Well, looking at the construction specs, it starts with the conductor. It's listed as an 18 AWG solid bare copper center.
About 1.02 millimeters in diameter, right? But here's my question. Why solid? Wouldn't a stranded cable be more flexible and easier to install?
It would be easier to work with, sure, but it would be terrible for the signal. This is where physics kicks in.
How so?
At high frequencies, like 3 gigahertz electricity actually travels on the outer surface of the wire. It's called the skin effect.
Okay.
So if you use stranded wire, the signal has to constantly jump between strands. That causes resistance and signal loss.
I see. So for a 500-foot run, you need that solid, smooth highway for the electrons to glide over.
Exactly, to keep the attenuation low.
Okay,
Yeah.
that makes sense.
Yeah.
So we have a solid core to reduce resistance,
Okay.
but you also have to keep interference out,
Right, and the specs highlight a dual shield design.
which is critical.
Yeah.
Because if you run 500 feet of cable, you've basically built a giant antenna.
It just wants to pick up every radio wave and power hum in the building.
I noticed something weird in the shielding stats, though. It lists an aluminum and polyester mylar foil with greater than or equal to 125% coverage.
Yeah.
Wait, how do you have more than 100% coverage? That sounds like bad math.
It does sound impossible, doesn't it? But it actually refers to the overlap.
Oh, the physical wrapping.
Right? The foil wraps around the cable and overlaps itself by 25%. This ensures that even if you bend the cable around a sharp corner, the foil doesn't gap open.
Because you never expose the core.
Never. And then on top of that, there's a tinned copper braid with 95% coverage.
So the braid handles low-frequency noise, and the foil handles the high-frequency stuff.
You got it. All wrapped in a black PVC jacket rated for 75 degrees Celsius.
Talk to me about impedance. The spec sheet says it is strictly controlled at 75 ohms plus or minus 3 ohms.
That is a crucial detail.
Why is that specific number so non-negotiable, though? Is a little variance really that bad?
It's disastrous. Think of impedance like the diameter of a water pipe.
Okay.
If your camera outputs at 75 ohms and the cable suddenly shifts to 70 ohms, it's like the pipe shrinking.
The signal hits a bottleneck?
Right, and it bounces back. In video, we call these reflections. It creates ghosting or just kills the image entirely.
So keeping that variance to just 3 ohms over 500 feet requires incredible manufacturing precision.
It really does. And it keeps the signal loss incredibly low, like 0.28 decibels at 1 megahertz versus 11.64 decibels at 3,000 megahertz.
Plus, it meets UL and RoHS standards. And for usability, it is compatible with both compression connectors and typical crimp systems.
Which makes it super versatile for installers.
Now let's talk about where this is coming from. The source is HDTV Supply. They call themselves a 25-year global home for AV products.
And honestly, browsing their site, it feels like they cover everything from these bulk cables to massive Wolfpack matrix switchers.
It is interesting to look at the reviews for a bulk cable. Usually people only review the fun stuff.
Right. But there is actual feedback here. We've got Jeffrey C. calling it excellent.
And Rico T as well. The one that stood out to me was from a buyer in Mexico who specifically shouted out Rachel Christian, the VP of operations.
I saw that. Don't let her go, they said.
It's a nice reminder that even when you are buying a $664 spool of industrial cable, there is a human element to the service.
Absolutely. When you are spending that kind of money on infrastructure, you want to know someone is actually checking the order.
That price point is definitely an investment. But for broadcast quality, you just can't skimp on the physical layer.
If the cable fails, the whole show stops.
So what does this all mean for you? It means that if you are building a studio or a sports bar system, the quality of your video isn't just about the screen.
It's about the copper in the walls. You can have the best camera in the world, but if the highway you are driving the signal on is full of potholes, you are not getting the performance you paid for.
So before we wrap up here, there's a thought to chew on. We're talking about 18-gauge copper being optimized for 3G signals.
Right.
As the industry pushes toward 4K and 8K, which require exponentially more bandwidth, are we reaching the physical limit of what copper can do?
That is the big question. At what point does the precision required for the physical infrastructure become so high that we have to abandon copper entirely for fiber optics?
Something to think about the next time you plug in a cable.